We are going to talk about what it means to take the composition of functions. This happens when you have two or more functions and you basically put one inside of the other, or you're combining them to make a more complicated function. This is often really important for use later on in your calculus class. But in order to do a composition of functions, we need to have two functions. So we take a look what we have right here. We have a function defined as f of x and a function defined as g of x. We're going to start basic first, and then we're going to get a little bit harder. If we take a look at part A, it says, as we read it, it's read f of g of 2. And what we want to do first is actually look at the number that is the most inside of anything else. Right now, this implies that we are going to put 2 inside of the g of x equation, which when we do that, we are going to get 3 times 2 squared, which is going to be 3 times 4, and we're going to get 12. So essentially, since g of 2 is 12, what we're really going to do then is actually then have 12 inside of the f of x equation. So when I put 12 into the f of x equation and I have 2 times 12 plus 1, I am going to get 25. So f of g of 2 ultimately is equal to 25. Now the next equation in part B, or expression, looks very similar to what we just had, except for now it's g of f of 2. So what this problem says is let's put 2 inside of the f of x equation first, and then put that answer inside of the g of x equation. So first things first, f of 2 is 2 times 2 plus 1. We are going to get 5. So ultimately then we're going to have g of 5 equal to 3 times 5 squared equals 25 times 3 is 75. If you take a look at this, these are not the same answer. And that's because on the left-hand side, we put 2 into g of x first, and on the right-hand side, we put 2 into f of x first. It gets a little bit more complicated when we end up having just a generic function inside of the other without a specific number we're trying to find this at. For example, let's look at C, where it says find g of f of x. And basically, if you look, this g of x equation is inside of the f of x equation. So wherever you see an x in the f of x equation, we are going to put, so if I model it, I put a big set of parentheses wherever there is an x in the f of x equation, and now I am going to put in the entire function of g. Once I have that in there, I'm going to want to simplify, and I can make that just 2 times 3x squared is 6x squared plus 1. Basically, this 6 times x squared plus 1 is the equation that would actually give me this value, this 25 value, if I went straight into plugging in 6 times 2 squared plus 1, 6 times 4 plus 1 equals 5, would give me straight up the 25. So you can find the full f of g of x equals expression first and then plug in the 2 like I did before, or we can do the 2 pieces that we had. Let's now do g of f of x, and what this means is we are going to, wherever we see in the g of x equation, wherever I see an x, I am going to put in the entire function f of x, which would be 2x plus 1 squared. Now, order of operations tells me I'm going to square this first. So when I FOIL out 2x plus 1, I'm going to get 4x squared plus 4x plus 1. Now my order of operations says I can multiply by 3. So I have 12x squared plus 12x plus 3. And that is the answer for when I'm finding g of f of x.